Okay, today we're going to finish up the last section of module number 1. We started the other day with writing linear equations or writing equations of lines, and we did the first 5 pages of the section, and now we're going to finish it up starting on page 6, and you should be looking at your information on your dashboard as we go through this. But the first section that we did was writing equations of lines in slope-intercept form, and you use slope-intercept form when you have the slope of the line, or you can calculate the slope, and you have the y-intercept, the point where the line crosses the y-axis. Now the question comes, what happens if you have the slope, or you can calculate it, but that the point that you have isn't on the y-axis. It's not a y-intercept. So what we do then is we use what's called the point slope form. And it uses exactly what the name says. It uses a point on the line and it uses the slope of the line. And the basic form for point slope form is y minus y1 equals m times x minus x1. And just like with point slope or slope intercept form, the x and the y are not only variables, but they represent points all along the line. So we leave them in the equation. We don't put anything in their place because they represent every point on the line. The m still represents the slope, and the x1 and the y1 represent this point, this specific point that you have, that you were given at the beginning of the problem. So if you take a look at page number 6 on your dashboard, you will see, or actually I should say at the bottom of page 6, there's the first practice there. It wants to know what the equation of the line would be when the slope is 2 and the point that you have is 1, 9. Well, this point is the x1, y1. So all we're going to do is plug these two pieces of information into that equation, and we have the point slope form. So again, you don't put anything in place of the y. In place of y1, we put the y1 from our point. Then you put the slope in, which is 2. Again, nothing gets put in place of the x, but in place of the x1, you put that. That is point slope form of this information. Now, sometimes you're going to be asked to change point slope form back into slope intercept form. So let's do that. To do that, you're going to do just like you do in regular algebra. You're going to get rid of the parentheses. So I have y minus 9 equals 2x minus 2. And then remember, slope intercept form just has the y by itself. So you add the 9 to both sides, and you get y equals 2x minus or plus 7. So 2x plus 7 is the slope intercept form for that same line. So this is point slope form. This is slope intercept form. Which way you leave your answer depends upon the directions. So you want to follow the directions. If you look at example number 2, still on the bottom of page 6, in this particular problem, you are told that you have a slope of negative 3/2 and it passes through the point 4, 6. And in this problem, it asks you to give both forms. So we're going to actually have to do the algebra that we did at the end of the last form. So again, this is x1, y1. And we'll plug it in. Again, nothing gets put in place of the y. In place of y1, we put 6. In place of the m, we'll put -3/2. And then nothing in place of the x, minus x1. This is point slope form. I'll just use an abbreviation there, PS, point slope. That's the first answer they ask you for. Then the second answer they ask you for is slope intercept. That means you have to rewrite this problem and get the y by itself. So the first thing you do is distribute. So I get y minus 6 equals -3/2 x plus, and again, make sure you know how to multiply fractions, but -3/2 times -4 is a positive 6. So use your calculator if you need to. And then we add the 6 to both sides to get the y by itself. And so when I add the 6, I get 12. So this is slope intercept. All right, now that we've taken a look at a couple of just basic examples for point slope form, let's move on to page 7 in your material. And there is a video on that particular page, and I'm going to encourage you to watch it. But there are a couple of other pieces of information. The first one has to do with parallel lines and perpendicular lines. Parallel lines and perpendicular lines. Okay, parallel lines have, and you know what parallel lines look like, they're like the edges of a railroad track. Parallel lines have the same slope because in order for the lines not to cross, whatever the vertical movement is and the horizontal movement is, which is what slope is, those have to be the same for both of those lines, otherwise they will eventually cross each other. So parallel lines have the same slope. Perpendicular lines are opposite slopes, which means that if one is positive, the other is negative. They are also reciprocals. So one slope is the other slope flipped upside down. Reciprocals. Okay. So for example, these are easy because if parallel lines, if one line has a slope of 5, the other one has a slope of 5. Or if one of them is -2/3, the other is -2/3. When it comes to perpendicular ones, if one slope is 2/3, the other slope has to be the opposite, so it has to be negative, and it has to be the reciprocal, so this one's flipped upside down. -3/2. If one of the slopes is -2, that's the same as -2/1. So the other one has to be the opposite, so it'll be positive. And if you flip it upside down, you get 1/2. So those are opposite reciprocal slopes. Those are slopes of perpendicular lines. So those two pieces of information we need to know. And we need to know that in order to write equations of lines that might be parallel to each other or perpendicular to each other. So let's see if we can't do that kind of a problem. If you look on page 8 in your material, it talks about writing some equations. And if you look at the bottom of page 8, let's look at practice number 1. I'm going to erase all of this to give us more room. But we'll put point slope form up here at the top just because we're not quite so familiar with it. Okay, practice number 1. It wants you to find the slope-intercept form of a line that is parallel. This is the symbol for parallel. Looks like just 2 vertical lines. It's parallel to y equals 5/4 x minus 17, and we want it to go through the point 8,7. So before we do it, let's just visualize what we're talking about here. This number is pretty big, so I'm not going to try to graph it, but just if I were to kind of just roughly design it, let's say that this line looks like this. It crosses down here, the y-intercept is -17, and it went up 5 and over 4, because that's the slope. Vertical movement of 5, horizontal movement of 4. So it goes up like that. But it wants you to take, the new line has to be parallel to this one. So if this one goes like this, whatever I come up with has to be going the same direction. But my new line has to go through this point. So the point, say 8,7, let's say it's over here. The new line has to go through that point, and it has to be parallel to the original one. And we're supposed to find the equation of that dotted line. So that's the situation that we're in. So let's see what we can do. The slope of this original line is this m value right there. It's 5/4. So what I always do is label them old slopes and new slopes. Old is what you're given, new is what you want. So our old m value is 5/4. Now the new one, we get by looking at the fact that they're parallel. If the lines are going to be parallel, we just learned that that means the slopes are the same. So if this slope is 5/4, the new one also has to be 5/4. They have to be the same in order for the lines to be parallel. Now we have enough information because we have the slope we're going to use and we have our x1, y1. They tell you what the specific point is on the line. So that's the x1, y1. Now we just plug it into the problem. Nothing in place of the y. Y1 is 7 equals the m value is 5/4. Nothing in place of the x. X1 is 8. There's the point slope form. And the direction said to put it in slope intercept form. So that means we have to rewrite this. So we're going to get rid of the parentheses first. Just basic algebra here. And again, using your basic math, 5/4 times 8 is -10. Now we add the 7. And we get that. 5/4 minus 3. 5/4x minus 3. That is a slope-intercept form. This line will be parallel to this one. If we were actually to graph them, they would be parallel to each other. And you can tell that because they have the same slope. But this line goes through that point. This one doesn't. We don't know what point that one goes through, but we know it won't go through that one because this one does. Okay, let's go to practice number 2. Practice number 2 wants point slope form, so we don't have to do any of that algebra at the end. We're just going to leave it at this case. And it says it wants it perpendicular. Well, this is the symbol for perpendicular. Looks like an upside down T. We're going to make it perpendicular to this line, y equals 3x minus 2. And they also tell you that it has to pass through the point 712. All right, we start with our old slope. So our old m value, again, the m is next to the x. So my old m value is 3. My new m value, remember we just wrote down that if they're going to be perpendicular, the slopes are opposite reciprocals. So the opposite of 3 is negative. And if you flip the 3 upside down to make the reciprocal, it's going to become 1 over 3 because this is 3 over 1. So here we go. This is the slope you're going to use. This is your x1, y1 because it has to go through that specific point. So here we go. You leave the y alone. Minus y1 is 12 equals m, which is negative 1/3, x minus x1. And because you were told to find the point slope form, you're done. And if you were to graph it, this line and this line would be perpendicular. That means that whatever way the first line went, the second line would be perpendicular to it. It would look like an X. And the second one would go through that point. Okay, practice number 3. Practice number 3 wants you to actually just show something. There's no equations. The first one is the line y equals negative 1/3 x plus 3. And the second one is the line y equals 3x plus 13. And the question says, show that the lines are perpendicular. Well, when we're talking about parallel lines and perpendicular lines, we're focused on the slope. So here's the slope of the first line. Here's the slope of the second line. Now, this is the question, whether they're perpendicular or not. They're telling you to show that they are, so we can assume that they are. But how do we know that? Well, we know that perpendicular lines have to have opposite reciprocal slopes. Well, you can say, well, I could just look at them and I can tell that these are opposites. One's positive and one's negative, and they are flipped over. If you flip over 1 over 3, you get 3 over 1. But the algebra way of showing that they are opposite reciprocals is to multiply the two slopes together, negative 1/3 times 3. And if they are opposite reciprocals, the answer will always be negative 1. Well, if you multiply a negative times a positive, you get a negative. And if you times 1/3 times 3 over 1, you get 1. So that's how you would show that they are perpendicular, is by showing that the product of the slopes is negative 1. Okay. Practice number 4. Write an equation in slope-intercept form. So we're going to have to do the algebra at the end. It is parallel to y equals negative x plus 3, and it has to go through the point 3, 1. Okay, old slope. You'll notice I'm using the same pattern on every problem. The old slope is this slope right here. Well, remember, there's not a number there, but it's automatically a 1. So this old slope is negative 1. The new slope, well, that's when we take a look at this. They're supposed to be parallel. That means the slopes have to be the same. So if the old slope is negative 1, the new slope is negative 1. And then it's going to go through the point 3, 1. So there's your x1, y1. Now we just plug the numbers in. Leave the y alone, minus y1 equals my slope, there's my slope, is negative 1, and then x minus x1. This is the point slope form. The direction said slope intercept. That means we have to get rid of the parentheses and get the y by itself. So get rid of the parentheses. You're just going to distribute the negative 1. So you get negative 1x or negative x, and then negative 1 times negative 3 is positive 3, and then you add the 1. And there's your slope-intercept form. Okay, last practice. The very beginning of this section, they were talking about trains leaving the Ginza station, and now they're revisiting the same set of trains. And they tell you that the trains must cross a road that runs perpendicular to the train track. So there's a road here, and the train track has to run perpendicular to it. So they are, in essence, perpendicular lines. The train track, it says, if the linear equation that models where the train tracks cross the road, if that equation is y minus 3 equals 1/2 x plus 1, this is the equation of the train track. It wants to know what is the point slope form of the linear equation that models how the road crosses. So we're looking for the road crossing, and it's going to go through the point 3, 5. So this is your original line. All the others that we did gave us the original line in slope-intercept form. This is just giving it to you in point slope form. So we want to know what is the point slope form of the road. This is the train track, and we want to find the road. The road and the trains are perpendicular. So we do the same thing. Our old m value, remember in point slope form, the m value is right next to the parentheses. So my old m is 1/2. Now, if these are going to be perpendicular to each other, then we have to do perpendicular slopes. So we have to do opposite reciprocals. This is positive, so my opposite's going to be negative. This is 1/2, so my reciprocal will be 2/1, or just -2. So this is my slope, and this is my x1, y1. Now we just put it into point slope form. Y minus y1 equals, my new slope is -2, x minus x1. And the direction said, what is the point slope form? Well, this is point slope form, so this is the answer to the problem. Okay. All right, that's the end of the actual algebra that you have to do here. Again, I encourage you to look through the whole lesson, watch the video, and then look at the additional practices that are near the end of the lesson. Once you are finished with this, then you will be ready to take the quiz on writing linear equations. You don't have to take that right now, but you can get prepared and take it as soon as you feel comfortable doing that. Okay.